Camera's wiggling. Okay, so let's look at this idea. Here we have the basic function, basic quadratic function. This parabola y equals x squared. I've plotted some values here. Okay, we have -2, +4, -1, 1, 0, 0, 1, 1, and 2, 4. So if we look at this function and this parabola, okay, first question I'm going to ask is this a function? Right? And you should already know that it is, okay, because it passes the vertical line test. Right? So we know it's a function. These are the x and y values for some of the points on this function. Now, if we talk about the inverse of this, I keep writing y. I should write f of x. I'm sorry. Okay? If I want to talk about the inverse of this function, so the inverse, this was on the previous video. If you haven't watched it, go back and watch it now. Okay? I want to take the y values and make them the x values. So we have 4, 1, 0, 1, 4. So I'm taking these, making them x values. Then I take the x values and I make them the y values. Okay? Now I'm not even going to plot these yet. When you look at this table of values, let me ask you again, is this a function? No, right? I hope you're saying no. Why not? We have repeated values of x that have different outputs for y. And we've talked about that at length. That's bad, right? It's bad to have the same input produce different outputs. That's a broken machine. So this inverse is not a function. So we would say for this, there is no inverse for this function. Okay? Now I'm going to erase this to prove my point. Okay, if we plot the point for if we plot the point for -2, I'm going to have to kind of guess here. We plot the point 1, -1, 0, 0, 1, 1, and 4, +2. We get this, right? Take a look at that graph. Look at the graph in pink. What do we notice? Doesn't pass the vertical line test. So we would say that this function has no inverse. Now there's a test that we can do. We don't have to go through this entire procedure every time, finding x and y values and flipping them. We don't have to do that every single time. What we can do is look at the function and do what we call the horizontal line test. Okay? Vertical line test tests to see if this is a function. This is a function. But it does not have an inverse because it does not pass the horizontal line test. The horizontal line test, you'll want to write this down, horizontal line test. This tests to see if something has an inverse. All right? So if it does not pass the horizontal line test, it does not have an inverse. And the word that we use to describe this, well, the phrase, is one-to-one. So what we say here is that f of x equals x squared is not 1-to-1. Okay? The reason it is not 1-to-1 is because it has the same output for different inputs. It does not pass the horizontal line test. So the idea of a function being 1-to-1 can be determined by doing the horizontal line test. If it doesn't pass the horizontal line test, then it is not 1-to-1 and it has no inverse. Okay? If I may, real quick, referencing the last video that we talked about, okay? When you looked at this function, right? We had a radical function that looked like this. Is this a function? Yes, it passes the vertical line test. Does this function have an inverse? Yes, because it passes the horizontal line test. So we would say, excuse me, we would say that this function is 1-to-1, okay, and therefore has an inverse, which we saw in the last video, right? The inverse looked like this, okay. If we look at the inverse of this function, this passes the horizontal line, or excuse me, the vertical line test, so we know this is a function, okay. Horizontal line test tests for 1-to-1-ness. test to see if we have an inverse, right? You're going to be asked about this on the Math XLs.